Hello and welcome to a ramble about question 11A of the IEB paper 1 of November 2023. You are welcome, you are most welcome. All right, it is broken down into three parts. Let's have a look at the first part, question 1I. Well, okay, let's look at the information, the context of the question. After some research, you decide that the best option for your online security is to have two unique passwords before opening important documents. Hey, these are very important documents. The first 10-digit password consists of two parts. Okay, so I'm guessing the second 10-digit password is going to be question 2. Okay, so the first 10-digit password consists of two parts. The first part is made up of 6 numbers. The numbers that can be used are the numbers from 1 to 9. How many unique 6-digit codes can be created if repetition is allowed? So my password could be 1111 or 9988 or things like that. Okay, so that means that we have, it's your 6-digit code, right? And for each of those slots in the code, you have 9 options, right? Because for each slot, you have the choice of any number from 1 to 9. Okay, so we're not including 0. If we had 0, then you would have 10 options for each slot. So you have 9 times 9 times 9, essentially you have right, 6 of these. Okay, 6 nines multiplied together, so you have 9 to the power of 6 options for your for that 6-digit code. And 9 to the power of 6 is 531,441. Okay, so just over 500,000 options for that 6-digit code. Okay. Next one. Maybe we should be checking with the memo. Yes, we should do that. Let's get the memo open. And we have 9 to the power of 6, 531,441. Yes. Right. The next bit of the question says, the second part is a 4-digit code compiled also from the digits 1 to 9, where repetition is not allowed. Okay, so for the first slot, we'll have 9 options, right? And then for the second options, for the second one, we'll have 8. For the next one, we'll have 7 options left, and then for the last one, we'll have 6 left. Okay, then the question says, how many even 10-digit passwords can be created by combining these two parts? Okay, so the key thing here is that the evenness of a number depends solely on this last digit, right? Because how do we tell whether a number is even? Well, can it be divisible? Is it divided by 2? But another way that we can quickly see whether a number is even is if it ends with 0, 2, 4, 8, 6 or 8. Okay, and in this particular instance, we know that it can't end with 0 because 0 is not allowed in the passcode. So in the valid passcodes, there can't be one that ends with 0. So really, the passcode would end with one of these 4 numbers. And if it is even, if it is not even, right, it will end with a 1, a 3, a 5, a 7, and a 9. And I want to emphasize this because naively, we might want to say, okay, 9 times 8 times 7 times 6 is the number of combinations or codes where we don't care whether it's even or odd, right? All we're thinking about is no numbers can be repeated. So that's the number of 4-digit codes that are possible under that condition, then half of them are even and half of them are odd, right? That would be the instinct for me, at least. But that is not the case, because even numbers can only add, in this context, they can only end with one of 4 numbers, whereas odd numbers can end with one of 5 numbers. So I am tempted to say that then 4/9 of the combinations will be even and 5/9 will be odd. But my brain power is a bit too limited to actually verify that. But that's something I'm tempted to say. But let's just hold that as a thought. Let's hold that as a question mark. Okay. So what I am going to say here is, no, what was I going to say? Yeah, I don't think it's correct to say 9 times 8 times 7 times 4 options either, because among these 9 options, there's a 2, right? For example. So you could pick 2 over here, and then you'd be left with 8 options here, 7 options here. But here you would no longer be left with 4 options, you'd be left with 3 of them, right? Because 2 can't be here because repetition is not allowed. But in the same breath, of the 9, you could choose maybe the number 5, and then you could choose the number 7 over here, and then you could choose the number 9, and then over here you would have 4 options left. So I think we need to consider the cases where this is now lang dry, because I feel like this is shorter. But I just can't bring myself to believe that I can just say 9 times 8 times 7 times 6, and then 4/9 of those ones that end with even numbers. Wait, let me think about this. 9 times 8 times, okay, yeah, I think let's just try and find, because the other way I'm thinking of, I think, is going to be painful. Okay, so 9 times 8 times 7 times 6. We agree that that is the number of 4-digit codes where we're only using the numbers 1 to 9 and repetition is not allowed. So 9 times 8 times 7 times 6 is 3024, right? So these are even, odd, the whole potato. I'm still drifting back to my initial. Okay, no. Tami, it's okay. Right, so let's carry on with this. So if we just look at the case where how many combinations are there that end with a certain number lav, right? So that number could be 1, could be 4, could be 5, could be 7, whatever, right? So we know that, okay, so if we think about it in a convoluted way, okay, we're going to go the convoluted way, but the reality is that there are 1/9 of this will be numbers that end with heart. But let's just show why that is in the convoluted way. So if this number is fixed, say we've decided that this number is the number 1, right? Then we know that we can't use 1 here, or here. So actually here we have 8 options for numbers. Here we have 7 options. Here we have 6 options. And then this last one we fixed. We've said it's the number 1 or the number 2 or the number 3, etc. So there are 8 times 7 times 6 combinations that end with the number 1 or more generally, whatever number, the number heart. Okay, right? So actually, here's a way more straightforward way of thinking about this problem. Actually, oh my goodness, we have really just gone in circles. Okay, so let's get rid of all of this. Hey guys, okay, busy here writing loves. Hey guys, it's not even February anymore. Okay, right. I think this is a more straightforward way to think about it. Here we said we're crossing out to 0 because 0 is irrelevant. Okay, we'll come back to that. Okay, so the more straightforward way to think about this problem, I think, is to think about it in two parts. Okay, so there are the 3 digits where pretty much anything goes. Okay, all we're told is you can't repeat any digits in there. You can use any number from 1 to 9, but you can't repeat any digits. And then there's the special last digit, right? And this last digit, we spoke about it. We said it could end as, it could be a 2, it could be a 4, it could be a 6, it could be an 8. It can't be a 0 because we're not using the number 0 in this passcode. Okay, so now I want you to think about the case where this code ends with a 2. Okay, how many options do we have for this number here? We can use number 1, 3, 4, 5, 6, 7, 8, 9. We have 8 options left. Okay, we had 9, but now we've used 2 at the end, so we only have 8. And then now, whatever number we've used here, we can't use it here, and we also can't use 2. So that means we're left with 7. And then for this last slot, we're left with 6. So how many codes are there that end with the number 2? It is 8 times 7 times 6 of them, right? And then we said, well, it could be a 2, it could be a 4, it could be a 6, it could be an 8. But the number will be the same for all of them. How many codes end with 4? 8 times 7 times 6. How many codes end with 6? 8 times 7 times 6. How many codes end in 8? 8 times 7 times 6. And again, another important thing to think about when you are doing these counting problems is, am I double counting anything? You gotta be careful of that. But because we're looking at which numbers end with 2, which numbers end with 4, which numbers end with 6, which numbers end with 8, those codes are all unique, right? Because even if you have 1, 5, 6, 2, if you then have 1, 5, 6, 4, that is a completely different code to the first one. So just by virtue of those last numbers being unique, 2, 4, 6, 8, we don't have to worry that we're double counting any of them. Okay, so in total, the number of codes that end with a 2, 4, 6, 8, or the number of codes that are even, is going to be 8 times 7 times 6 times 4, right? 4 being the number of options over here, right? We've got 4 options that we could choose from for that last number. Okay, and that becomes times 4. Okay, so that is 1, 3, 4, 4. Okay, so now the question is, how many even 10-digit passwords can be created? So now we are bringing in these guys and combining them with these guys. Okay, so for the first part of the password, we have 531,441 options, and each of them could be matched with any of these ones. 1,344 options over there. So this is the total number of even 10-digit passwords that are possible. So let's just quickly get what that is. Very big number. Okay, times 1344. Right, 714,256,704. Okay, memo. What does the memo have to say? The memo says the same thing, which is awesome. Okay, righty doos. Then from there, let's move on to the last part of the question. it says the second 9-digit password, okay, so the first one was 10 digits, this one is 9 digits, has to be a number greater than 600 million, with the last digit being divisible by 3. How many 9-digit passwords are possible if you can use the digits from 1 to 9 with no repetition allowed? Okay, so this time we have 9 slots to fill. Okay, we are told that it has to be a number greater than 600 million. So the options here are, let's just highlight. Okay, the options are 6, 7, 8, or 9, right? So there's 4 options for that first slot. Okay, and the last digit has to be divisible by 3. Okay, so let's highlight. Last digit divisible by 3. So that means the options here are 3, 6, 9. Again, if 0 was in the picture, it would be inside here, but we are only using the numbers from 1 to 9, so 0 buzz off. Right, and then the condition for the numbers in between is that no repetition is allowed, and they must be numbers from 1 to 9. Okay, so I am seeing a couple of scenarios, right? I'm seeing a scenario where we have a number starting with 6 and ending with 3. A number starting with 6 and ending with 9. Remember, it can't end with 6 because we can't repeat. Then we have 7, which can work with 3, 6, or 9, right? And then the same goes for 8. 8 can work with 3, 6, and 9. But 9 can only work with 3 or 6. Okay, I'm just going to shrink this so that everything is in view. Screenshots being taken in the midst. Oh, the downside of doing that is that, okay, anyway, is that my things are no longer aligned with the slots. I guess I could shrink the slots. The problems that I have that turn out to not be problems are so hilarious. I can be so rigid in my thinking that it takes someone else to just kind of say, you can really get out of this rut very easily. Okay, right. And then as for what happens in between, right, we now have 7 slots. Okay, 1, 2, 3, 4, 5, 6, 7, right, where 2 numbers have been taken out of the pool. So for the first slot, we'll have 7 options, for the next one 6 options, and so it goes until we have 1 option for the last one, right? Because there are only 7 numbers left for us to choose from, no repetition allowed. And so the number of combinations that will start with 6 and end with 3 is 7 factorial, right? Because all we're changing is the stuff in the middle, okay? And that's going to be the same for the number of combinations that start with 6 and end with 9, the number of combinations that start with 7 and end with 3, and so on. So we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 ways to start and end the code. Okay, so there's 10 ways for us to start and end the code. Okay, we've listed those out manually because the conditions were a bit interesting. But as for what goes in the middle, for each of those codes, there are 7 factorial possibilities. And so the total number of combinations possible is going to be 10 times 7 factorial. And 7 factorial is 5040, I think. How do I do factorial here? Where's the exclamation mark? Oh, there it is. Right, yes. So we have here 50,400. Not so many options, but anyway. So those are the number of 9-digit passwords possible according to me. Let's see. Yes, indeed. Those are the possibilities.